slope equals rise over 1. No, slope equals rise over run. Yeah, okay. So change in y over change in x. That's my slope. Oh, sorry, I'm just doing a little studying. Want to do well on that test. So let's look at a set of data that's collected from students, and it compares the number of minutes spent studying for a test and the percentage on their test. Now notice this doesn't look like a beautiful line, but we can draw a line that it does represent something similar to a line. So I'm going to kind of eyeball it and look at these data points and see if I can draw a line that fits it best. Now what we're doing is we're really just using our eyes. Statisticians have a way where they can actually calculate this and figure out using the distance squared between those little data points and that line, and to make it the least possible distance. But that's about our line, and we can use that line to help predict. Now notice there's a correlation between the number of minutes spent studying for a test and the percentage on the test. Now correlation just means relationship. So depending on the number of minutes I've spent studying for the test is a more likelihood of getting a higher percentage. And I can use that line to look at how many minutes I spent studying for that test and follow it up to see about what my score will probably be. Now there are always data points that are a little outside that. This just shows a correlation or a relationship, and it's a positive relationship. So the more minutes I spend studying, the better I will do on my test, the better my percentage will be. So let's take a look at another correlation. Now this is the number of injuries per team at soccer games compared with the number of minutes of team warm-up. So our independent variable is x, and that's the number of minutes spent warming up, and we're going to look at how many injuries occur with that. So just taking lots of different soccer games, and we can plot these points. So if you look over to the right, I actually showed you my data table. So my data table is kind of like a T-chart, and the first point I already put on there is they had 0 minutes of warm-up and 5 injuries on that game. The next one is 15 minutes of warm-up and 7 injuries, and 25 minutes of warm-up and 1, and we've got 50 and 0, 40 and 1, we've got 25 and 6, and we're just going to plot the rest of these points on here. These are ordered pairs. And we're going to see if there is any correlation. If there's any linear correlation, we can make something that looks like a line with these data points. Now sometimes the correlation is stronger than others. I mean, you can really see the line. And other times it's a little more difficult to see, and sometimes there's no correlation at all. But if we look at this, we can kind of see a line forming here. And in our line, it looks like the number of minutes spent warming up is actually going to decrease the injuries. So instead of a positive correlation this time, it's actually a negative correlation. So it's going downhill or has a negative slope. So we can see that the number of minutes spent warming up decreases the number of injuries. Now I want to point out something on the y-axis. The 1 really should have an extra line in between there, since each one represents 0.5. Now this doesn't matter for the negative correlation, but as far as accuracy goes, your intervals need to be accurate when you do that. Let's look at one more. So if we have x equals IQ, starting with 100 and going up to 180, and y equaling GPA, or grade point average, we can see that there are dots all over the place. So if you have 180 IQ, that doesn't necessarily mean you're going to have a higher GPA. So if we look at these, we can see there's actually no correlation between IQ and grade point average, which means doesn't matter your IQ, your grade point average does not depend on it. It's all about working hard. So we say this is no correlation. We can't really find a line of best fit. I have a lot still to learn.